بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين. السلام عليكم. Bonjour tout le monde. Toujours à la partie communication sans fil et pour le ZIG BEE. On va commencer par cette petite vidéo, après on passe à notre cours. Donc c'est une vidéo en anglais. What is ZIG BEE and how it works?
Its key characteristics, the different types of ZigBee networks and types of devices. Also, we will cover some basics of ZigBee communications, and of course, we will see some applications. Let's get into it. What is ZigBee technology? ZigBee is a wireless standard that defines a set of communication protocols for short-range communications. This is just half of the definition, and I will get into the complete one shortly. The question that anyone may ask is, why did we need a new standard for short-range communications? We already have Wi-Fi and we also have Bluetooth. Well, ZigBee standard is specially built for control and sensor networks. The objective of this technology is to monitor and control devices. Both Bluetooth and Wi-Fi are not quite suitable for this specific application of wireless communication. So what is ZigBee addressing in its standard? In a nutshell, ZigBee is a standard that addresses the need of very low-cost implementation of low-power devices with low data rate for short-range communications. So this can be seen as the full definition of ZigBee standard. ZigBee is one of the most commonly used standards for Internet of Things. It is also an open source standard that was developed by ZigBee Alliance, which is an organization created in 2002 and consists of hundreds of companies today. Okay, moving forward. What sort of applications can benefit from ZigBee technology? The most prominent applications are in home automation, medical data collection, and industrial control systems. The main purpose is to use wireless communication to gather information or perform certain control tasks inside a building. Remember, we mentioned that ZigBee was designed for control and sensor type networks. In ZigBee home automation, we basically have a home automation controller with a software application that controls smart devices. The controller is also called a central hub or simply a hub. The gateway is the interface between ZigBee network and the web. The gateway is connected to the internet and it will let the homeowner control his or her smart home devices from virtually anywhere in the world. Some of the smart home devices that ZigBee supports include lights, door locks, switches, smoke detectors, fans, appliances, and so many others. Let's take a look at a simple diagram of ZigBee network. This diagram shows you how different wall switches control different lights on the house. Notice that the wall switches are not connected with any electrical wire, and that's because they are battery operated. By switching on and off any of the switches, a message will be sent wirelessly to the controller, which will relay that message to the appropriate light bulb to either turn it on or turn it off. Another interesting application of ZigBee network is the remote monitoring system. Here, a patient can be wearing some ZigBee sensors that can collect information such as blood pressure, body temperature, heart rate, etc. This information will be sent through the ZigBee gateway over the internet to a personal computer in a hospital so that a physician or a nurse can monitor the patient's health. You might think, why we can't use Wi-Fi or Bluetooth technology for these devices? Well, the issue is that Wi-Fi uses a lot of power, which is bad news for battery-powered devices or devices where low power consumption is important, such as sensors in this example. Also, all devices here use low data rate, while Wi-Fi uses mainly high data rate. So it is an overkill to use Wi-Fi in this application. Bluetooth will also not be a good fit because Bluetooth network can only support a maximum of 7 devices in a network, while ZigBee is designed to support hundreds of devices on a network.
Hey, video creators! Stuck with the static...
Some general of ZigBee standard. Low power consumption. ZigBee devices can typically operate for several years on a single battery. In many ZigBee applications, the device spends most of its time in a power-saving mode, also known as sleep mode. We will show how devices can go to sleep mode later in this video. Low data rate. It varies between 20 kilobit per second up to a maximum of 250 kilobit per second. That's low. However, this is sufficient for the applications that ZigBee is intended for. Compare this rate to Wi-Fi rate, which is about 11 megabit per second. That's 50 times higher than ZigBee. With Wi-Fi, devices can stream video, audio, and pictures. For Bluetooth, the data rate can go up to 1 megabit per second, so no video streaming, but devices can still transmit audio and pictures. With ZigBee, we can only transmit packets of data, but that's all what we need. Short-range communications. The range of ZigBee devices can go up to 75, sometimes 100 meters indoor, and for the outdoor, it can go up to 300 meters or even more. Network join time. It takes a ZigBee device around 30 milliseconds to join a network. Compare that to Wi-Fi device where it takes up to 3 seconds and for Bluetooth where it takes up to 10 seconds. Support small and large networks. ZigBee networks vary from several devices to thousands of devices. To be exact, ZigBee can support up to 65,000 devices in a single network. Well, that's in theory, but practically that won't be feasible. So 240 devices is practically the maximum. Compare this to Wi-Fi, Bluetooth, where 32 devices is the maximum for Wi-Fi and 7 devices is the maximum for Bluetooth. Low cost of products and cheap implementation. The reason for this is the simplicity of the technology. ZigBee standard is a lot less complex than Bluetooth standard or Wi-Fi standard. Also, the standard is an open source protocol, which makes it cheaper for manufacturers to build ZigBee technology because they don't have to pay any license fee and they don't have to pay any royalty. Security. ZigBee network uses AES algorithm for data encryption and data authentication. This is the standard that banks are using for their online operations. It is also commonplace in government agencies, so it is one of the most robust and secure cryptographic algorithms out there. Regarding the frequency spectrum, there are 3 frequency bands currently assigned to ZigBee. The first frequency band is the 868 MHz and it includes only 1 channel. This band is allocated in Europe. The second band is the 915 MHz, which include 10 channels and can be found in US and Australia. The third band is the 2.4 GHz band, and that is available across the world. Now, once a ZigBee network is established, only one channel will be selected for that network. This is important. Only one channel. Okay, in this part, I will be talking about the different types of ZigBee device.
Donc, on va s'arrêter ici pour cette partie. On va passer à la partie théorique. Après, on revient à notre vidéo. Donc, dans notre cours, nous sommes arrivés le mode non coordonné totalement, le CSMA/CA. Dans le mode non coordonné, il y a d'émission de beaucoup de B-count, donc pas de synchronisation entre les différentes nœuds du réseau. Les nœuds veulent émettre des données, doivent utiliser le protocole CSMA/CA non sloté, c'est-à-dire que le début d'une émission se fait dès que le médian est jugé libre sans atteindre le débit d'un éventuel slow. Cependant, même si l'algorithme est dit non sloté, il se base tout de même sur une unité temporelle discrète appelée période de back-off pour pouvoir retarder plus ou moins l'émission d'une trame et éviter les collisions. On passe maintenant sur le principe de fonctionnement du CSMA/CA. Donc, la station voulant émettre écoute le réseau. Si le réseau est encombré, la transmission est déférée. Si le média est libre, la station transmet un message RTS read to stand avec les informations sur le volume de données et sa vitesse de transmission. Le récepteur répond par un message CTS, clear to send, qu'il reçoit toutes les stations. La station effectue l'émission des données. À la réception de toutes les données, le récepteur envoie un accusé de réception et toutes les stations voisines patientent alors pendant le temps calculé à partir du CTS source. Nous avons dans un réseau ISO 2.15.4, les trames data sont très courtes et le débit très faible du fait de l'utilisation d'un protocole de type RTS. CTS serait très coûteuse. Donc, après avoir attendu un nombre aléatoire de périodes de bake-off, si le médium est libre, la trame de données est émise. Le mode coordonné ou bien balisé, dans le mode coordonné, une ou plusieurs entités du réseau, périodiquement, des trames appelées balises ou beacon, tout membre de réseau qui entend cette balise peut utiliser la réception de cette trame pour se synchroniser avec son émetteur et se servir de lui-même comme relais. Ce mode de fonctionnement permet les meilleures performances sur le plan énergétique car une fois l'information transmise au relais, le nœud communicant peut se smoller. De plus, les messages en attente étant stockés dans la mémoire du relais. Un nœud peut choisir de se réveiller selon ses besoins et demande alors des données en attente. On parle alors de transfert de données indirects dans une topologie en étoile car tout échange sur le réseau passe par le relais. On parlera par la suite sur ce relais le coordinateur d'étoiles. Vous avez dans la figure ci-dessous illustre le fonctionnement de transfert de données dans une étoile aux cellules générées par un coordinateur unique. Nous avons le transfert de données direct et illustré par l'envoi du message 1 de type data. Le nœud envoie directement ces données au coordinateur de l'étoile, puis en redore. Le nœud de destination récupère ces données de manière indirecte et le message Bacon 2 annonce les données en attente pour tous les nœuds. Le nœud de destination écoute le Bacon, constate que des données sont en attente et les réclame par le message Data Request 3. Le coordinateur peut alors transmettre les données en attente et envoyer le message Data pour 4. Donc, vous avez en noir, c'est le coordinateur. En bleu, ce sont les entités complètes, FFD ou bien réduite RFD. La flèche double, c'est le message Bacon diffusé. La flèche simple, ce sont les données. Le principe de base de routage ZIG BEE, donc du fait de la mémoire très limitée des nœuds, le routage ZIG BEE suit le principe de base suivant. Si la table de routage contient une entrée qui correspond au routage demandé, il faut router le paquet selon cette entrée. Si elle ne contient aucune entrée et si la mémoire libre le permet, il faut lancer le process de découverte route. Sinon, il faut router le paquet selon le routage hiérarchique en arbre. Pour le ad hoc on demande vector routing, routage à la demande, donc ce principe de fonctionnement, donc lorsqu'une source veut atteindre une destination, elle diffuse par inondation un route request jusqu'à atteindre la destination et chaque routeur intermédiaire ne conserve que la meilleure route. La destination revoit un route replay sur le chemin de moindre coût vers la source. Lors de la réception d'un route replay, la source met à jour sa table de routage, donc la destination next stop et path coast. L'algorithme de routage hiérarchique 3 routing, dans le cadre de cette topologie hiérarchique, l'adressage est fonction de la topologie. Il suffit donc d'observer l'adresse du nœud de destination pour déterminer à quel voisin envoyer le paquet. Le problème principal de cet algorithme de routage est que de par sa structure arborescente, il ne permet pas la redondance des liens comme dans un réseau mesh. Si un lien vient à tomber, c'est toute une partie du réseau qui se retrouve isolée. La couche applicative APL et les profils de ZigBee. Donc, nous avons la couche applicative, c'est la couche de niveau plus haut. C'est elle qui détermine la façon dont on veut utiliser tous les niveaux inférieurs, et ceci pour une application donnée. La couche APL, Application Support Layer, est associée à plusieurs entités protocolaires et le module Security Service Provider qui peut gérer les fonctions de sécurité, authentification et cryptage. Le module APS Application Support Sublayer qui est un soutien aux applications pour la mise en liaison des dispositifs et les services de messagerie et de module ZIG BEE Device Object qui permet la découverte des dispositifs et des services au même titre que la couche Service Discovery Protocol de Bluetooth. Vous savez que les profils d'application définissent quels sont les messages envoyés par une application donnée et les dispositifs avec le même profil interopèrent de bout en bout. On passe à notre vidéo et dans la prochaine vidéo, Inch'Allah, on va voir les réseaux industriels sans fil Wireless HART.
And also the types of ZigBee networks that can be formed. We have three types of ZigBee devices: coordinator, routers, and end devices. ZigBee coordinator is the most capable device. It is the device that starts the network originally. So it is the root of the network, and there is exactly one coordinator device in each network. The coordinator performs many tasks. I will only cover the most important ones. Channel selection. So before the coordinator starts the network, it automatically performs a channel scan to select a good channel to be used for the network. By good channel, I mean a channel with the least interferences. It also assigns a unique identifier for the network. It allocates unique address to each device in the network. So anytime a device joins the network, the coordinator assigns an address to it. The coordinator also initiates and transfers messages inside the network. Routers. They act as intermediate nodes between the coordinator and the end devices. They are responsible for routing traffic between different nodes. They are responsible for routing traffic between different nodes. They also receive and store messages intended for their children, meaning end devices. At certain occasions, routers can allow other end devices to join the network. End device contains just enough information to talk to the parent node, which can be a coordinator or can be a router. They may sleep, which makes end devices a suitable choice for battery-operated devices. All traffic to an end device is first routed to its parent. As you see in this example, device A cannot transmit directly to device B. Data has to go through the router. This is because in case device B is asleep, the transmitted data will be stored in the router until device B is active again. Then the router will send the data to device B. And by the way, the end device is responsible for requesting any pending messages from its parent when it wakes up. There are three types of network topologies that ZigBee supports. Star topology, which is the simplest and less expensive to implement, and that is the advantage of this topology. There are no routers in this architecture. Also, end device cannot communicate directly with another end device. Some of the drawbacks of this topology is that if the coordinator fails, then the whole network fails. Also, the range of the network is limited to the range of the coordinator itself. Now, we have mentioned an application of ZigBee in medical data collection, where that application can be implemented in a star topology, as you can see in this picture. In mesh networks, every node is connected with the neighboring node, except for the end devices that cannot be connected directly with each other. Now, if a device A wants to transmit data to device B, the message will hop from one device to another until it reaches its destination, as you see here. The main advantage of mesh network is that if one of the nodes fails, it does not incapacitate the entire system, since data can be rerouted using a different path, as you can see here. And this is called a self-healing process in mesh networks. This is an example of mesh network implemented for home automation. The home automation can always add more devices. If we have 4, 5, or 6 devices, a star topology can still work for home automation. But as more devices are being added, then mesh topology will be the right one to go. Tree topology, it's not very different from a mesh configuration, except that the routers are not interconnected. However, there is another configuration called cluster tree network, which let routers to be connected to expand the range of the network, as you can see in this example. Earlier that the coordinator assigns only one channel to the network upon network establishment, which means that all devices will have to share this single channel to communicate. So how can they share this medium? There are two methods that describes how ZigBee devices can access the channel: contention-based and contention-free. I'm not going to get too technical, I promise that, but it's worth describing these two methods. In the contention-free method, the coordinator dedicates a specific time duration called guaranteed time slot to each device. And obviously, the time slots cannot overlap with each other. Let's see how this GTS allocation is done. We are going to explain this through a star network as an example, one with 5 devices plus the coordinator. So to correctly assign the GTS, the coordinator needs to ensure that all the devices in the network are synchronized. And to achieve this, the coordinator transmits periodically a message called beacon. Once the devices receive the beacon, they will adjust or sync their clock to the coordinator clock. The reason this is accomplished first is because the beacon contains information on when each device can transmit data. So at this time, all devices know ahead of time when they can transmit. Each device will then wait for its turn, and transmit its data at that assigned time slot. The coordinator transmits the beacon periodically, so the same operation repeats over time. The time slot allocation may differ from one beacon period to another. Not all devices need to transmit every beacon period. So, as you see here, device 2 and 4 are not transmitting in the second beacon period. And this can be pre-programmed in the coordinator by the developer. Because end devices know ahead of time when they can transmit, they will go to sleep and they will only wake up to either transmit data or to listen to the beacon. This is what enables low power consumption in ZigBee standard. For the conjunction-based method, devices do not need to be synchronized. The carrier sense multiple access collision avoidance mechanism is used by all devices to access the channel. Let's explain that. In CSMA CA, anytime a device wants to transmit, it first goes into receive mode to detect if there is any signal in the channel, and it will only transmit the data if the channel is clear. However, if the channel is not clear, the device backs off for a random period of time and tries again. That's about it for this tutorial. I hope you liked it.
Donc, nous sommes arrivés à la fin de cette vidéo. Je vous remercie infiniment pour votre attention et à la prochaine vidéo, Inch'Allah. On va terminer la suite. Merci beaucoup et à la prochaine.